If you've ever faced the frustration of slow curing sealants on your double glass production line, wasting time, delaying orders, or risking sealing quality, you're not alone. In our short preview yesterday, we touched on the key causes, but today's full-length guide dives deep into real-world solutions, step-by-step machine adjustments, and pro tips to avoid repeated issues. Whether you're a line operator, maintenance tech, or plant manager, this video will turn this common headache into a quick fix. Part 1. Demystifying slow curing sealant root causes. We briefly mentioned two main causes earlier, but let's break them down with details you won't find in a manual. 1. Unintended sealant reaction, rare but critical. This issue isn't just about black sealant, it's about why the reaction happens. A real case from a partner plant: their team mixed a new batch of primary sealants with leftover secondary sealants from a different manufacturer in the same extruder. The result? A thick, blackened paste that didn't cure for 72 hours. How to spot it early? Before full extrusion, do a test squeeze on a scrap glass panel. If the sealant turns dark within 5 minutes and feels sticky, not tacky after 1 hour, stop immediately. This is a reaction, not normal curing. Quick fix: purge the entire extruder system with clean solvents per your sealant supplier's specs and start with fresh, matching sealants. 2. Incorrect black sealant curing agent ratio. Too little black sealant sounds simple, but it's often a calibration issue, not just adding less. Many operators miss that the secondary pressure booster cylinder can drift over time. Even if you set it to 10% ratio, it might only be delivering 6%. The hidden risk: a 2-3 underdose might still cure slowly, but it weakens the seal's water resistance. Our tests show 8% ratio, cures in 24 hours vs 12 hours normal, 30% lower water tightness. 5% ratio, fails to cure fully, seal peels off in 3 months. Key metric to track: after adjustment, check the sealant's tackle-free time (TFT). It should be 4-6 hours for most IG sealants. Verify with your supplier. Part 2. Step-by-step booster cylinder adjustment. What you'll need: digital pressure gauge calibrated within 30 days. Screwdriver set for cylinder valve adjustments. Scrap glass panels to test sealant after adjustment. 3-step calibration process. Check current pressure. Locate the booster cylinder's pressure relief valve on the side of the two-component extruder. Attach the digital gauge if it reads below 0.8 megapascal for most machines. This is the problem. Adjust in small increments. Turn the valve clockwise a quarter turn only. Wait 2 minutes, then test extrude. Even an 1/8 turn can change the ratio from 7% to 9%. Verify with TFT test. Apply a 10 mm bead of sealant to scrap glass. Mark the time. If it's tuck-free, no residue on a gloved finger in 5 hours, you're set. If not, repeat step to no more than 3 total turns. Over adjusting causes brittle sealants. Part 3 to 3 mistakes to avoid from 10+ years of IG plant experience. The common errors that make slow curing worse. 1. Skipping the test squeeze. Rushing to production without testing sealant consistency wastes time. A plant that lost 200 IG units because they ignored this step. 2. Overheating the sealant. Some operators turn up the extruder temperature to speed up curing. This actually breaks down the curing agent. It compares sealant cured at 25°C normal vs 40°C overheated. The latter never fully hardens. 3. Ignoring sealant expiry dates. Old black sealant over 6 months from manufacture loses potency. If we open a expired can, you'll see its separated watery top layer and won't mix properly. Got a slow curing scenario you want to see solved? We specialize in double glass lines and sealing robot lines. Drop a comment on the video.